You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Security Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Continuity of operations, COOP, refers to the ability of an organization to sustain essential functions during disruptions, whether caused by natural disasters, cyber attacks, or system failures. Unlike disaster recovery, which focuses on restoring IT infrastructure after an outage, COOP encompasses a broader organizational perspective. It includes maintaining mission-critical processes, ensuring personnel know their roles, and preserving the ability to deliver core services under stress. For example, a government agency may continue citizen-facing services through alternate facilities while IT systems are restored separately. COOP emphasizes resilience of operations as a whole, not just the recovery of technology. Business Impact Analysis, BIA, plays a central role in continuity planning by identifying which services are most critical and what consequences occur if they are disrupted. A BIA examines financial costs, reputational harm, regulatory penalties, and operational dependencies. For instance, if payroll systems are unavailable for 2 weeks, the impact may include employee dissatisfaction, compliance fines, and union disputes. The BIA helps organizations prioritize recovery and allocate resources, ensuring COOP focuses on services where interruptions would cause the greatest harm. Without BIA, continuity planning risks protecting the wrong priorities. Recovery Time Objective, RTO, and Recovery Point Objective, RPO, provide measurable inputs for planning. RTO specifies how quickly a service must be restored after disruption, while RPO defines how much data loss is acceptable, measured in time. For example, an RTO of 1 hour means the service must be back online within 60 minutes, while an RPO of 15 minutes means only a quarter hour's worth of data can be lost. These targets guide technical design, capacity requirements, and investment decisions. Setting realistic RTOs and RPOs ensures COOP aligns with business tolerance for downtime and data loss. Identifying essential versus non-essential services is another key step in COOP. Essential services are those that must remain operational to preserve mission-critical functions, while non-essential services can be delayed or suspended. For instance, an airline prioritizes flight booking systems and aircraft communications as essential, while internal training portals are considered non-essential. Prioritization ensures that limited resources during an incident are directed toward keeping the most impactful services running, preventing a scattershot approach that dilutes effectiveness. This separation of services helps focus continuity investments where they matter most. Capacity planning fundamentals rest on demand forecasting and maintaining headroom to absorb unexpected load. Forecasting uses historical usage trends, anticipated growth, and business cycles to predict future demand. Headroom refers to the buffer capacity above normal demand that ensures services remain stable during spikes or partial outages. For example, a retail site may forecast higher demand during holiday sales and maintain 30% additional capacity as headroom. Without forecasting in headroom, systems may operate fine in normal conditions but collapse under stress, undermining continuity goals. Scaling strategies: vertical and horizontal support capacity planning in different ways. Vertical scaling increases resources within a single system, such as adding CPU or memory to a server. Horizontal scaling adds more systems, such as additional servers in a cluster. Vertical scaling is simpler but has physical limits, while horizontal scaling provides flexibility and resilience by distributing load across multiple nodes. For instance, a database may be vertically scaled for performance, but also replicated horizontally for fault tolerance. Understanding these trade-offs helps organizations design capacity models that remain stable and cost-effective during stress. Resource right-sizing ensures organizations do not overinvest or under-provision capacity. Right-sizing balances cost, performance, and resilience by matching resources to actual demand while retaining flexibility. For example, a cloud-hosted service may reduce unused compute instances during low demand while reserving additional instances for peak hours. Over-provisioning wastes money, while under-provisioning risks outages. Right-sizing ensures resources are continually optimized, supporting both fiscal responsibility and continuity. Seasonal and burst workloads must be factored into capacity planning. Some industries experience predictable surges, such as retailers during holiday seasons or tax agencies during filing deadlines. Others face unpredictable bursts, like sudden viral traffic to a news site. Planning for these scenarios involves elastic scaling policies, on-demand resource allocation, or pre-provisioned buffers. For instance, an e-commerce company may temporarily increase capacity before Black Friday to handle millions of concurrent sessions. Addressing both predictable and unpredictable patterns ensures services remain available regardless of demand spikes. Dependency mapping reveals upstream and downstream services required for continuity. A payroll application may depend on authentication services, databases, and external banking networks. If any of these dependencies fail, the payroll system itself cannot function. Mapping dependencies ensures that continuity planning covers not only primary applications, but also the systems and third parties they rely upon. By visualizing interconnections, organizations can address hidden risks that would otherwise disrupt critical operations during incidents. Runbooks and role documentation transform planning into actionable procedures. Runbooks provide step-by-step instructions for continuity tasks, while role definitions ensure individuals know their responsibilities during events. For example, a continuity runbook may specify who initiates failover, who communicates with leadership, and who validates restored services. Documentation removes ambiguity and prevents delays caused by confusion. Well-crafted runbooks and role assignments turn theoretical continuity plans into practical, executable workflows that support rapid recovery. Clear communications and escalation channels are essential to continuity events. Communication plans define how updates flow between operations teams, leadership, employees, customers, and regulators. Escalation channels ensure incidents are addressed at the right level of authority without delay. For example, a security team detecting a ransomware attack must escalate quickly to executives who can authorize major continuity measures, such as invoking a disaster recovery site. Without structured communications, organizations risk miscoordination, conflicting messages, and delayed action. Ultimately, co-op and capacity planning are about preserving mission-critical operations under stress. They recognize that disruption is inevitable and ensure organizations are ready to continue delivering core services even in degraded conditions. By combining impact analysis, prioritized recovery, forecasting, scaling strategies, and strong governance, organizations build resilience into their operations. Continuity is not about perfection, but about ensuring that essential functions persist, customers retain trust, and recovery is guided by disciplined, well-prepared plans. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Capacity buffers and safety margins provide breathing room to handle unexpected load beyond forecasted demand. A buffer represents extra resources provisioned above normal usage to absorb sudden surges, while safety margins ensure systems remain stable during partial outages or failures. For example, an online learning platform may plan for 20% more capacity than peak forecasts to handle unplanned spikes during exam periods. Without buffers, even small surges can tip systems into failure. Safety margins transform capacity planning from a static calculation into a resilient defense against unpredictable stresses. Auto-scaling policies offer elasticity, but must be designed carefully to avoid oscillation and over-provisioning. Policies that react too quickly may cause systems to repeatedly add and remove resources, leading to instability. Cooldowns time delays built into scaling actions. Allow the system to settle before further adjustments. For example, a streaming service may scale up after sustained high CPU usage for 10 minutes, rather than reacting to a momentary spike. Properly tuned auto-scaling ensures that capacity adjusts smoothly and efficiently, balancing responsiveness with cost control. Cost-aware capacity planning requires weighing options such as reserved versus on-demand resources. Reserved resources provide predictable capacity at lower cost but require long-term commitments. On-demand resources are more expensive but offer flexibility during bursts. For instance, a financial institution may use reserved instances for steady-state workloads like transaction processing, while relying on on-demand resources for quarterly reporting surges. Optimization strategies also include spot instances or hybrid models. Cost-aware planning ensures organizations remain fiscally responsible while still meeting resilience objectives. Service degradation plans define how to reduce features gracefully when capacity is strained, preserving core functionality. Instead of complete outages, organizations prioritize essential functions while disabling non-essential ones. For example, an e-commerce site under heavy load may disable personalized recommendations or advanced search but keep checkout services online. This approach ensures customers can still complete critical tasks, even if the full experience is unavailable. Service degradation acknowledges that partial service is better than none, protecting both user trust and business continuity. Supply chain and vendor capacity dependencies directly affect continuity planning. If upstream providers cannot scale during demand surges, downstream services suffer regardless of internal capacity. For example, a cloud-based payroll service depends on banking APIs for transfers. If the bank throttles requests, payroll cannot process regardless of internal resilience. Continuity plans must include vendor risk assessments, contractual capacity guarantees, and contingency measures. Ignoring these dependencies creates hidden vulnerabilities that surface only during stress. Metrics provide visibility into capacity health and allow proactive action. Utilization metrics measure how much of a resource is currently in use, while saturation metrics indicate how close systems are to reaching limits. Error rates capture when service quality degrades under stress. For example, a spike in error rates during moderate utilization may reveal bottlenecks in application design. By tracking these metrics continuously, organizations detect early warning signs and intervene before capacity failures cascade into outages. Load testing and stress testing validate whether planned capacity actually meets expectations. Load tests simulate typical demand, while stress tests push systems beyond expected limits to reveal breaking points. For example, an airline may conduct stress tests on its booking platform before holiday travel seasons, confirming it can handle peak simultaneous transactions. These tests uncover bottlenecks, validate auto-scaling policies, and build confidence that continuity measures will succeed. Without testing, capacity planning remains theoretical and unproven. Runbook-triggered scaling and manual overrides provide structured responses during incidents. Automated systems may handle most scaling actions, but human operators need the ability to trigger scaling manually when conditions demand. For example, if a monitoring system predicts demand spikes before a product launch, operators may manually provision extra resources in advance. Runbooks document when and how to execute overrides, preventing hesitation or overreaction. Structured overrides combine the speed of automation with the judgment of experienced staff. Monitoring service level agreements, SLAs, and service level objectives, SLOs, forms part of continuity oversight. SLAs define contractual obligations for uptime, while SLOs define internal targets aligned with customer expectations. For example, a cloud provider may promise 99.9% availability in its SLA, while an enterprise sets an internal SLO of 99.99% for customer-facing portals. Monitoring these metrics ensures organizations detect deviations quickly, address them, and remain accountable to both customers and contracts. SLAs and SLOs translate technical performance into business commitments. Periodic reviews of capacity models are essential as usage patterns evolve. Systems that scaled adequately last year may fall short under new demand, architectural changes, or regulatory obligations. For instance, a pandemic-driven surge in remote work forced many organizations to revisit their VPN capacity models. Regular reviews ensure continuity strategies remain accurate, relevant, and aligned with current business conditions. Stale models create false confidence and leave organizations unprepared for today's realities. Alignment of continuity plans with business continuity and compliance obligations ensures technical efforts remain grounded in organizational priorities. Regulatory frameworks may impose specific requirements, such as HIPAA's mandates for healthcare continuity or PCI DSS for financial data handling. Business continuity planning ensures technical measures are matched with broader processes such as alternate facilities, workforce mobility, and customer communication. Aligning co-op and compliance obligations transforms capacity planning into a holistic, organization-wide discipline rather than a purely technical exercise. Capacity planning and continuity of operations are not static deliverables but ongoing, measurable programs. They require continuous monitoring, adjustment, and validation to keep pace with evolving risks and demands. By combining buffers, auto-scaling, cost optimization, service degradation strategies, and dependency mapping, organizations ensure stability under stress. COOP and capacity planning safeguard not only technology but also the trust of customers, employees, and regulators. They embody resilience in action, proving that continuity depends on preparation, discipline, and the ability to adapt as conditions change. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.